We'll be looking at the real number line today, a very useful abstract concept that we've invented to help us visualize and understand what's happening to numbers and relationships and operations. So let's take a look at it. It's not that difficult. So the real number line is conceived of as literally a line, something like this. There's a few important features that are going to be on the real number line. First of all, there is a head here, and this represents essentially the positive direction. Okay, so as we go towards the right, we're moving in the positive direction. Okay, that means towards the left is going to be the negative direction there. Sometimes people will actually have another head on the other side. Some people like to draw it to indicate like you can go infinitely in either direction, but you don't really need that. You can just leave it with the arrowhead on one side indicating the positive direction, and we understand it goes on for infinity in either way. So in addition to this, we'll often define an origin. Okay, so an origin here we'll label with an O, and typically this is the 0 mark of the real number line. So this is the origin. And then from here, we might add some hash marks to indicate different distances from the origin. So this might be, 1, 2, 3, and then as we go towards the negative direction, past the origin here, we go to -1, -2, and -3. Okay, something like this. So here we have a number line. Now, what do we do with a number line? Well, what we're going to do is you can sort of plot points on the number line, right? So you can imagine, let's say the number 1/2, right? Where would that be? Well, that would probably be somewhere over here, right? So this would be the location of the number 1/2. And so we can plot it as a point. And you can do this for any point that you want. For example, over here, we must have the point -2.5. That's going to live over there. We could imagine maybe over here, we're going to have the point pi, right? Because that's like 3.14. And maybe over here, somewhere over here, we might have this is the square root of 2, because that's going to be something like 1.4 something, right? So any real number can be plotted on the real number line. You essentially give it a coordinate, then you can draw the point on that line. Now, sometimes you might have this real number line with a slightly different scale, right? So you could imagine if we copy this here, perhaps it goes in tens. This is 10, 20, 30, -10, -20, -30. That's also perfectly viable, okay? So you can create whatever scale you want here on the number line, and then you can plot specific points to represent numbers and their position on this number line. So let's see something else that's important about what this shows us about real numbers. So the important property that the number line reveals is that real numbers are ordered. Okay, what that means is that any two real numbers can be compared, and you will know which one is smaller, which one is bigger, and you can put them in order. And it's literally the order you have right here on the real number line. That's the order of the real numbers as they go from smaller to bigger. Let's show you an example here. So let's say we want to plot 2 points on the real number line. Okay, so 2 and 3. That's what we've got here. We can say that 2 is less than 3. Okay, it's possible to do this comparison. We could also say 3 is greater than 2. Okay, so it's the less than symbol, and this is the greater than symbol. Let's stick with the first one for now. Now, how can we explain why this is true? How do we know that 2 is less than 3? Well, we can sort of see it literally on the real number line, right? So it is to the left of 3, so it is smaller than 3. Real numbers are ordered. And another way we can express this is that if we were to subtract the bigger number and the smaller number. So let's do like 3 minus 2, right? So we subtract the smaller from the bigger. We should get a positive value. We should get some positive number. So what I'm going to say is if we do 3 minus 2, then this value It's going to be 1, and that's going to be greater than 0. It's going to be a positive amount. That's how we know which numbers are bigger than another. We can do this comparison, and if we get a positive number, then you know that they're going in order like that. So basically, there's a rule here. We can generalize it, and it's basically any number A will be less than B if the bigger number B minus A gives you a result that's greater than 0. Okay, so let's just try another comparison to make sure that this works, right? So let's try choosing the number -3 and how about -1? Okay, so the idea is if we have we're saying which one is smaller, right? -3 should be less than -1. Okay, because if we do -1 minus -3, what do we get? Well, this is the same as -1 plus 3, right? And that's going to equal 2, and 2 is greater than 0. So it works, okay? We're getting a positive value here. If we had reversed it, if we had said -1 is less than -3, then when you try to do this comparison, you will get a negative number, so you know that's not true. Okay, so the concept of real numbers being ordered seems really simple, seems really obvious, but actually we will wind up learning about other kinds of numbers that are not ordered. So this is not a property that every single type of number has. Real numbers do. While we're at it, why don't we talk about some other inequality signs, right? So we've mentioned the less than symbol. We have the greater than symbol. And essentially we're reading from left to right, right? So some A is less than B, or A is greater than B. And there's another pair of symbols, very important. We have this one here. This is the less than or equals to. Okay, so here A is less than or equals to B. And finally, we have the greater than or equals to. Okay, so 4 inequality symbols that can only make sense if numbers are ordered. And real numbers are ordered, so we can compare real numbers using these symbols. Other numbers are also ordered, like rational numbers or natural numbers, integers. These are also ordered, so they can also be compared this way. But like I said, we will learn about some other numbers in the future that are not ordered. They cannot be compared this way. Okay, so let's take a look at just one last thing with the real number line. And that is that real numbers often have units. Okay, what I mean is, as we look at numbers here, we say this is 2. Well, a lot of times it's going to be 2 what? 2 something, right? This real number line might represent, for example, distance. If it represents distance, then the units here would be in maybe meters, right? And so if it's in meters, you might add a little m here to represent the units. Or perhaps it doesn't represent meters, maybe it represents like a speed, maybe miles per hour or kilometers per hour. So maybe that's what this 2 represents, 2 miles per hour. It can be anything, right? You could be measuring calories. You could be measuring money, right? Maybe dollars or euros or yen, whatever you want. Or it could even be like stars, right? So maybe this is how many stars does this restaurant have, or does this hotel have, right? It has pi stars. A pi star hotel sounds like a good one for me. So that's just another property you might often see on a real number line. If you can also sort of imagine taking a copy of this real number line, rotating it 90 degrees and placing it right here, and what we'll have is another axis. And so it's sort of changing this coordinate line into a coordinate plane. And now when we plot points on this coordinate plane, you might have a coordinate like this that's at 2, 1. And so you can plot a position in 2-dimensional space now using essentially a pair of real number lines set at right angles to each other. But we're not going to focus too much on that right now. So a real number line is not a very complicated thing. It's literally conceived of as a line, and you can plot points on the line. You can plot their coordinates. You can use the coordinates to compare numbers with each other, generate relationships on the real number line, as we will see in our next lesson.